Okay, so thank you all for coming. The workshop session that you have joined is Slurm and Advanced Slurm, and we'll talk about what Slurm is. But first of all, I'm Kristen Finch. I'm the staff scientist with the Hyak team and the facilitator. So I take care of a lot of help tickets with folks who are asking, how do I do this or that on Hyak? I'm a former postdoc in biology, and so I was a user of Hyak for about 2.5 years before I started this position. And so I hope that that gives me a good perspective to what you're dealing with and the type of deadlines that you have. I was working in genetics and bioinformatics as well as machine learning, so that's a little bit more about my background. But thank you all for coming. I'm working on a training schedule to start during the fall. It'll probably be every other week instead of every 2 weeks, and with some sessions that are in person. We'll be covering some of these same sessions, but also brand new sessions. Our learning objectives for today are to understand the benefits of parallel computing and scheduling jobs, understand how accounts and partitions determine the research computing access that you have, understand the concept of our community idle resources, or the checkpoint partition that you might be familiar with, become familiar with the job types and job submission, and how to request a GPU job. Unfortunately, I won't be talking about GPUs a whole lot today, but just to show you the differences that you would use with requesting a job to request a GPU job, and then how to monitor the job queue. And so I'll ask Kyla to put the workshop materials list into the chat, as well as the additional materials. And we have a post-workshop survey, and as well as the next, so basically almost all of the links you can put in up to the recording of the last workshop. If you missed it, I released the Linux Basics workshop as a video on YouTube. And so if you missed that session, then that is recorded for you and can be found there. All right, and one thing I forgot to mention last time is that if you have any questions about using Hyak, all you need to do is to open a help ticket, and that's to send an email to help@uw.edu with Hyak in the subject line, and that will start a help ticket for us. Okay. So can you drop that post-workshop survey link into the chat when you get a chance, Kyla? And then I'm going to go ahead and get started. So what we need to do first to get started is to log into Hyak. So whatever way that you do that, I want you to get that fired up. So it might be that you use a command prompt, a Windows PowerShell, a terminal on Mac OS, or any other bash, or like Git bash, any other shell software that you have, or shell terminal software. Just going to make this bigger. And now I'm going to log in with SSH and my username. So I want you to put your username here, not mine, at clone.hyak.uw.edu. Okay. That's going to ask for my password. As I'm putting in my password, it's going to hide that from me as this key cursor. So it's just for security purposes, in case someone is looking over your shoulder, or in case you're sharing your screen on Zoom, you can securely put in your password. And then it's going to have me do my Duo two-factor authentication, which I like to have a push notification sent to my phone to allow access that way. Okay, so now you see the login screen for Clone, which is our 3rd generation cluster on Hyak, which is our cluster kind of ecosystem, or the whole research computing infrastructure for University of Washington that the Hyak team manages. All right, so the way that Hyak works is that we all offer to University of Washington professors, researchers, that they can purchase resources to be added to the cluster. And when they do that, they end up with an account for their entire group. So their whole group will get access to these resources with 24/7 priority. But if those resources are not being used in the moment, they're called our community idle resources. And so they go kind of into this bucket or this partition that we call checkpoint. And I'll talk a little bit more about that. But the first thing that I want to talk about with Slurm is how you understand what access you have to resources on Hyak. And the best thing to do is to use the command Hyak alloc. And so this is going to look a little bit different for everyone because we're all part of different accounts. I'm part of the UWIT account. And then I used to be part of the Wasser lab, so I'm part of the Wasser account. And this is how you find out what access you have. So I have a little visual aid. Slurm is a job scheduler software that we use. It stands for Simple Linux Utility Resource Manager. And the way that you can kind of think of it as it's what is happening in the background to do this 3D kind of Tetris to work in different dimensions for scheduling the jobs after you request them. So the dimensions that Slurm is working in are accounts, which you see here in this column on your Hyak alloc, and partitions, which you see in the partition column. So first of all, you're always going to be requesting a job under a certain account and from a certain partition. And I'll explain what a partition is in a little bit. And then the next dimension, kind of the second dimension of your job request, is what you're actually requesting. So how many nodes you need, how many CPUs, and how many GPUs you need, as well as the number of processors and everything like that goes into this dimension. And then finally, the maximum time or the time limit for your job. So everyone can give a job that's a certain time limit, and that's kind of the third dimension. So Slurm is kind of the hostess at the restaurant. You know, we have these different parties or these jobs that need resources. These people need somewhere to sit. And the host at the restaurant knows how many people there are, what tables are available, how long everyone is going to be staying at those tables, or are they close to leaving, and it will schedule that based on these three dimensions of information. So we'll talk a little bit more about that as we go on. But what I can see here is that my account, I have access to several partitions, being part of the Hyak team, and the Wasser lab has one partition. And you can also see what is free and what is used of those partition resources. So in this very first account and partition combo, all of the CPUs that are grouped within that partition are free right now. None of them are used. But if we look down at the Wasser lab, they're using 3 CPUs. And so there are 77 free, and it also tells you the memory that is free. So this is really a good resource to tell you what kind of jobs you can request. And so if you have different partitions, you can kind of hop around and try to get your job filled on each one of these partitions, or whichever one is going to fill first. So you're not kind of bumping into your lab mates or your group mates and trying to do something that is not available to you. Okay. Next, I'm just going to show maybe what a few other Hyak allocs look like. So one of our users, Masa Aguchi, I'm gonna just pick on you for a second, Masa. I know that you have a demo account. So if you're working under a demo account, your Hyak alloc is going to look like this, where you don't have any partitions and your account is called demo. So instead of partition pending, from now on, you're going to use partition checkpoint or CKPT or the other partitions. So a partition really is just a group of computers that we have grouped under these different categories. So here's what I was talking about with our checkpoint CKPT partition. We also have CKPT generation 2 computers, and then CKPT-all is a partition that is made up of the generation 1 and generation 2 computers. So if you just need a computer and you don't have a preference on what kind of processor it is, Intel or AMD, you could use checkpoint-all, and that would give you the access to the most idle resources. We also have compute. You might see big mem or huge mem or ultra mem. These are computers that have more memory allocated to them. And then some of the newer ones, CPU, G2, 2x memory, and then listed some of the GPU partitions that are there. All right, the next command that I want you to try is sinfo. Sinfo just gives us a look into all the computers that are available on the Hyak ecosystem. So it has the different partitions listed out here, and it shows you which of the hosts or which of the specific computers fall under that partition. So big mem, we have N 3011, 3133, and so on. You see that in checkpoint, we have many hosts listed here. Those are all ones that if they become idle, the community is allowed to use them. And you should know that if your group has paid for resources, and that someone is probably going to be using them in the time that you're not using them through the checkpoint partition, but when you're ready to use those again, the job that is running there will be preempted, which means it'll be kicked back to the queue and sent to another point, another node or another CPU job task by Slurm. So you're always going to have access to your resources. And so even though you think, okay, my group has bought a slice and it equals this as one computer, it's actually that you have several hosts that you can send jobs to, and you get access to that from like a compute partition. And this is how we really guarantee that you can always have a computer that's available for you. Okay. I see one question in the chat. Do the G or N prefixes to nodes mean anything? Great question. Yes. So the G prefix is actually our GPU host names, and our N prefix are just the HPC or the regular compute CPU host names. And then the Z, I'm not exactly quite sure, but I know that we have a special kind of host for a group in particular. All right, so that is what I wanted to say. So really, a partition is just a group of resources that you have access to when you call upon those resources. Yeah, we just covered a lot of material. Okay, going down. I wanted to show one more, Hyak alok -u. You can look at the Hyak alok for any user on Hyak if you know their username. So I'm going to use Kyla. She's one of our interns. Username, because I wanted to point out that we do have accounts available through the Research Computing Club that are from account STF. So this is the student technology fee, and these are computer resources that have been purchased through student technology fees that are made available for students for extracurricular or for project-based research computing, not for courses, just for their own individual research. And so Kyla, if you could please put the link to the Research Computing Club website where you can apply. So if you're a student at University of Washington and you're attending this workshop now, and you see a demo account listed as your access right now, you would be able to apply for a STF account. And you can see that they have many resources available, though I will say that during the school year, they get a lot of action. So you might send some jobs and have to wait for them to complete or to be queued. Okay. All right, so I'm going to go ahead and get into the example material that we have for us today. Before I do, though, I do want to point out that a lot of this tutorial is under construction, but will be added as a tutorial on our documentation website. So right now, it kind of starts on this page, scheduling jobs, underneath the tutorial Hyak basics, but I'm going to make this into a standalone Slurm tutorial by itself where you can walk through. But this gives you a nice vocabulary resource, and it walks through some of the commands. So I'm kind of following along with this, though I've made some improvements in the last few days, so there will be some updates coming. Another resource that we have is under Compute and Scheduling Jobs, where we have our just kind of rundown of Slurm, the different flags that you can use for SBatch, and it goes over some of the commands and the environment variables. But you should know that this workshop, nor the documentation seen here, can never be a replacement for the full documentation of Slurm, which is just a wealth of knowledge. So if you go to the main website and you go to man pages, they go over in depth all of the commands that we're going to talk about today, which is really just a handful of the commands that are available. It's really because the point of what I want to be today is to give you access to let you try out some template scripts that you can adjust and use in your future research so that you have a template, you can change it to fit your needs, and then move forward kind of troubleshooting on your own from there. Okay. So I'm just going to minimize this. We can focus over here, clear my screen. All right, so what I want us all to do is to not be working in our home directory. If you were at the workshop last week, we talked about how your home directory has limited storage quota of only 10 gigs. And if you exceed that storage quota, yes, this is being recorded, thank you. If you exceed that storage quota, you are going to have a lot of trouble moving forward in the future. So I want us all to go to change directory, cd/gscratch/scrubbed. And this is a community storage area that you have access to. So if you ls, you'll see that many users of Hyak have been using this space. You should know that the resources or the files here will be deleted automatically if they're not used after 14 days. So just keep that in mind. But for today, it will be good to do the next steps in a folder under your username. If you already have one from last week or you've been working in a scrub directory already, that's great. But I'm going to make a new directory for myself with the command mkdir for make directory. And I'm going to call this Kristen F. So please don't call it Kristen F anyone else out there, because that is the name that I am using. You can use your own username. And now if I cd into Kristen F, I have a directory, it is empty, I haven't added anything here. I want everyone first to copy the resources that I have prepared for us today, which includes the scripts and the data that we'll be using. So I need you to use the command copy cp-r for recursive. We need to use the -r flag because we're going to be copying an entire directory. And the directory is located at /sw, which is a full path that I'm giving here, /hyak101/basics. And then that's the directory that we want to be copied into the directory where we are now. And the way that we signify that we want it to copy the directory from there and put it here is we end with a dot or a period. So that's just shorthand for copy here. And now if I ls, I see I have a directory inside of Kristen F, or my working directory for right now, which is called basics. So let's change directory to open basics. And let's take a look around with ls-ltr, which gives us our entire list of files in long format with the time that they were last edited being the most recent at the bottom. And these are all the same timestamp actually because I just copied them. So yours should all look the same here. Okay, so we have several scripts in here. We have one container, which we're going to talk about, and we have a data directory. We can list what is in the data directory from outside of the data directory like this. We'll talk about these a little bit later, but that's just to give you a little bit of a rundown of the kind of materials that I prepared for you today. We're going to get through as much of this as possible. All right, so very first thing that we need to do when we're starting to request a job with Slurm is understand that we have different job types. And the first job type is a interactive job. So whenever you log in to Hyak, your command prompt gives you clues about where you have logged in or which computer on the entire cluster you have logged into. And for everyone, it's usually clone-login3 or clone-login1. It might also be clone-login2, but I think that one is being used for something else. So I'm FinchKN, that's my username, at clone-login3. And then where I am right now on the file system is in my basics directory. So if I print working directory, I see the full path or the address of where I am on the clone infrastructure or the file system in basics. Okay, but clone login node is the front door of the server. And so we don't permit very heavy duty computing jobs to occur on the login node. So if you've ever tried to do something on the login node and it has been killed automatically, that's probably one of our automated programs that we use to seek out projects or commands that are using too much memory and processing power, and we kill them because we need this login node to be available for everyone. You might have also seen that if you have something running on the login node long-term, you will get an email from Arbiter2, which is our program that does the automated kind of notifications about too much data usage. So that's what that is. So whenever you're looking in our documentation and it says you need to start an interactive job on a compute node, this is what that means. So the Slurm command that you use is salloc, and you can give it your account, and you know what, this is the best time for this. So let's first do Hyak alloc so that you all have that in front of you. And now let's do salloc, and we're going to do -- account equals, I'm going to do UWIT. If you have another account here like I do, I could have done Wasser, do whatever your account is that you want. If you don't have a account, you just have demo, just leave this blank completely. It will automatically go to demo. Also, if you only have one account, it will default to the account that you're going to. But just for demonstration's sake, I'm going to do -- account equals UWIT. Don't do this unless you're me, because no one else has access to this account. -- partition equals, if you're a demo account, you should do checkpoint. If you're any other account access here, you could do compute or whatever works for you there. Okay? Next, we're going to just ask for one CPU. So -- CPUs - per - task equals 1. Just one CPU -- mem for the RAM of the job. It's going to be a very small job, so just 10 gigs. And then -- time equals, I want to do just 15 minutes. Oh, says that that is spelled wrong. Yes, so Hyak is very sensitive to spelling and capitalization errors. Partition, yes. There we go. All right, so what's happening here is it's saying that it has assigned a job ID, and that my resource job is available now for me on N3054. That's the host name. So this is a compute job. This is a completely different host or computer than the login node. So you see now that my command prompt has changed to show me the new host name. If you don't specify partitions, CPUs, mem, etc., what are the default values? Is there a difference if I do srun versus salloc? Okay, so I'm gonna answer. The difference between srun and salloc is they're almost interchangeable, but we recommend to use salloc. Srun is really meant to be used only for the MPI jobs. So if you are running kind of sub jobs or sub processes. So salloc is really the way to go here, folks. And then what are the default values? I'm not exactly sure, but I think that CPUs per task equals 1 is the default. So it just opens up one CPU. Invalid QoS specification. That probably means that you're not using the correct account and partition combination that you have available. So I would try again, or I would just try to do salloc and no account, but just -- partition equals checkpoint, and just do it this way and see what happens. So I can't do it. Oh, I spelled it wrong again. I would just try it this way. Okay, that did it. Great. All right, so I would like everyone, if it is possible, for you to open up another terminal window. Okay. So what I wanted to do was to have us all start a second terminal, because on one side you can monitor the job queue, and on the other side you can be working, so that we can see our jobs going in real time.
I think there's another message in the chat.
Okay. CPU, by default, Slurm will allocate one processor per task. Default value is def mem per node, and the maximum value is max mem per node. Okay, great. Yes, I wasn't sure. So probably Slurm has the answer. Slurm documentation has the answer to that. We do sometimes set our own defaults in our version of Slurm as well. All right, I'm back where I was. So what I wanted to do is on the second one, I should still be connected to that job, even though my terminal kind of crashed. That job should still be going. So here's a command that can be helpful to watch the queue in real time. So if I just wanted to see my jobs that are in the queue, I would use sq-u and then my username. Oh, it did die. So I'm going to go salloc -- partition equals checkpoint -- time equals 15 minutes. So once that starts, now I'm at N3319. And so if I do sq-u Finch kn, I see that I have my interactive job running on this screen, but I can monitor the queue from this side. So if I really want to monitor the queue in real time, I can use watch, and -n means for this watch command, what it does is it reissues the next command every 10 seconds. So if I put sq-u Finch kn here, then it opens up this other screen, and it's going to refresh this screen every 10 seconds so that I can see my jobs in real time as they develop. So let's just leave that open if you can. And now I need to go back to my scrub directory. If you're seeing me kind of typing fast and wondering how I can move through the directory so quickly, I'll show you again. If you change directory and you start typing GSC, then you use the tab button, then it will just start to complete what you're typing there. So that's how you can move through. I'm inside basics. All right, so the job that I want to show you here is that I have made a script in Bash. I'm going to open it up with the job or with the text editor called Nano, so that I can see the color coding of this command, of the commands. So the point of this workshop is not this script. I just wanted to show you something that would it would make a job that can be any length of time that I want it to be. And so this job is, it's really just going to do a sequence of numbers. And once it reaches the end point of the sequence of numbers, it will print this message, sequence complete, iterations from start to end. And it's going to take a starting point, which can be 0, for example, and an ending point, which could be 1 million or any number for these two, as long as they're one after the other. It's going to start at the starting point, and it's just going to count in its head, not printing a message. Once it gets to the ending point, or that this variable I is equal to the end point, then it's going to print my message. So the whole reason for making this script for you is that it kind of symbolizes a command or a software that you might be using in your research. And so I want to show you how in your interactive job you can issue this command. So as you can see, the loop script here, that's what I was just looking at, is in green. That means that it is executable. If you ever are making a script and it's not executing, you would need to use change mode or chmod plus X, and then the name of that script to make it executable. But it's already done for you here, so you won't have to do that. That's just a note for later. How you execute a command is you do // or how you execute a script, // and then start typing your loop script here. Oh, and of course, I have to put the starting and ending numbers, so it's given me the error message that I coded there. So I'm going to go from 0 to 1 million, which is just going to take a few seconds. So I can see on this side, this keeps updating. Now my job has been running for 3 minutes. And now it's complete. So sequence complete, iterations 0 to 1 million. Let's try it again. Let's get the time of this. So if you add the command time, it will actually tell you precisely how long it took to execute the command. Just a few seconds. Yes, so it only took 5 seconds to count from 0 to 1 million. So it can go pretty fast. If you did 0 to 10, it would be done immediately. So, okay. So that is an interactive job. You are on a job on a compute node. You're no longer, taking up traffic on the login node, and you are free to execute heavy-duty commands here. This could be good for jobs like building software or doing some heavier data analysis, but that doesn't take a long time to complete. So it could be scripted jobs, jobs with longer run times, but when you have a longer job, so something that's going to take longer to run, you wouldn't necessarily want to do this on an interactive node or an interactive job. Instead, you might want to submit it as a script so that it will just be running in the background. So you can get your script ready, you kind of press go, you shove it off a cliff, it goes for however many days it needs to go for, and then it completes and it tells you that it's done. You come back later and it only tells you it's done if you ask it to, but you can come back later and then look at the results. So to end this job that I am in right now, I can just put exit, and that will stop the interactive job that I was just using. So it says relinquishing job allocation, and this is your job ID. If you ever have some error in some job that you're trying to do and you start a help ticket with us, if you keep this job ID, that is incredibly helpful because all of the jobs that we're making right now are logged in our system under these job IDs. So if something weird is going on, we can really help investigate your job best if we have that job ID. Okay, so I'm back on the login node. As you see, I have Finch KN at clone login 3. I'm back in my home directory for some reason, so I'm going to go to gscratch scrubbed Kristen F basics. So really it was because I started that job when I was still in my home directory, and then during the job I navigated to the basics directory. Okay. The next thing that I want to do is to explain how you would send that same job that we were just looking at as a batch job. So you see over here on my queue, it's watching my queue, that job is off now. It has canceled and it's gone. The script that I've prepared for you today to start to submit loop script is called loopjob.slurm. So let's open that in Nano so that we have the color coding. I've done a lot to kind of explain all of the pieces of this script down here, and it's really just future-proofing so that folks can follow this tutorial on their own and have an explanation of what all of these things are doing. But really what we're going to be discussing is this part up here. So when you submit a job to be running in the background, you're using a command called sbatch. And these flags up here, they pass the flags or the messages, your options, to sbatch with these sbatch directives. So just like with salloc, how we had -- partition, -- mem, all of these things are carried over here. And what I've selected for you today is we're going to call this job. We're actually going to give it a name called loop job. We can send it to the checkpoint partition. You can send it to, again, whichever partition you have access to. We're going to send it to one node. So that's really just one computer, which has 192 CPUs available. That's what most of our computers have. But it's just going to be one task. It's very short, as we saw, so we're only going to request 1 GB of memory, and only for 5 minutes because we saw that it only really takes 30 seconds, or even less than 30 seconds to execute this job. And then everything that would be printed to the screen, like we saw before, how it says sequence complete, number of iterations from 0 to 1,000 or 1 million or whatever it said, is going to be saved into a file called, so this is shorthand, this %X stands for loop job. So it just grabs this and puts it here. And then the %J grabs that job ID that Slurm is going to save for us. And then it's going to call this file a .out, and it's going to make a directory called log and save that there. So this is the directions or the instructions that you're giving Slurm and saying, I want this type of job. That's what you're setting up in this part up here. But then the command is the same command as before, but that's what you're passing. So this is really what the job is doing. And this part up here is just your options that you're asking for in the job. And then this part down here is just explanation that you can explore at a later date. So to exit the Nano app, you want to use Control-X. And if we didn't make any changes, then it won't ask you to save as or anything like that. So I'm going to go ahead and use sbatch to submit loop job.slurm. And it's defaulted to the Wasser account because that was the very first account I was ever added to. And we see that here's my job started up on the queue. All right, so let's see what else has come up in our directory. Now we have a directory called log. Remember, I said that that would start itself. So we're going to change directory into log and ls-ltr there. And we see that we have one file called loop job. You see over here, the status or the state of my job now is cancel job. That means that it's done. So it was completed, it's canceling that. And so my output file should be complete. So if I use the cat command or concatenate, it will show us sequence complete, iterations 0 to 1 million. And it kept the time and said this took about 5 seconds. So you can see where the utility of this comes in, that you have some long-running job and you make a script to send that command like we did here with loopjob.slurm. And the script consists of this, where it's a bash script that you send your sbatch directives, you send your command, and it executes that for you, and it saves your output to a file. It will save any output messages as well as error messages there. All right, I feel that I should pause for questions. If you have a question, just go ahead and unmute. Is the node the CPU or GPU? Okay, so the job that we just submitted with the loop job is just a CPU job, and that's because I didn't give it any GPU instructions. So I'll show you how to request a interactive GPU job. The first thing that I should show you though is that this is a command for how to. What was the command you used to update SQ with your, yes, so username. So, okay, so here on this side, it's showing right here. So it's actually using the watch command, but that's the main one. So if I stop this with Control C, you see it there, it's watch -N10, which is saying every 10 seconds. The default is every 2 seconds. And then SQ-U Finch KN for whoever is asking. To put there, you need to put your own name on there, your own username. Okay, so a GPU job. So I'm gonna put, whoops. I'm gonna put this command into the chat because it's rather long. But I'm gonna type it out. So sinfo, remember that was giving us all of the information about the partitions and the hosts that were underneath those partitions. This is going to be similar. So we're gonna say sinfo-p, and we're gonna ask for the checkpoint nodes for now. This is a way to find out what GPUs are free across all of the GPUs that we have, or what GPUs are under the idle community resources at this moment. We're doing node host, comma, CPU, so CPUs, state, comma, free, mem, comma, gress, comma, gress used, -s, node host, pipe, grep, -v. This is why I just wanted to copy and paste it here. Not mul, null. Okay, so this is a great tool. It's showing you all of the GPU hosts. It's showing you what GPUs are being used or are free, the free memory on those GPUs. And then this is showing you the GPU partition name. Well, actually, they would have dashes instead of this colon. And then how many GPUs are actually available under that partition. So 8 GPUs. And then this one is how many are being used. So there's a lot of free GPUs right now, or GPUs not being used. I prepared to show you the A40 and A40 command. So what that looks like, if instead of doing a CPU job, you wanted to submit a GPU job on an interactive job, you do salloc -p or -- partition. So there are also short versions of the commands in Slurm. So -p or -- partition are the same thing. So checkpoint -- it looks really the same until the very end. So -- CPUs -per -task equals 1 -- mem equals just 10 gigs -time equals just for 5 minutes, just to see that it's there. And this is what is different. So if you're requesting a job from a GPU from checkpoint, you're going to use GPUs equals, and then the type of GPU that you want. So A40 colon, and then just one or however many GPUs you want to be requested from that. And now you see that I have my host is a G host. So it's G3071. That's how you know it's a GPU node that's opened up. And then this is my job ID again, and we see that my job is running over here. How do we know that it's a GPU node? We can use NVIDIA -SMI which will give us the information about the NVIDIA GPU that is running this. So that's if you want to use a checkpoint GPU. I'm going to exit. I'm going to do Hyak alloc again. So I have some GPUs available to because I'm part of the UWIT account. So I have some GPUs that are available to me and other members of my group. So I'm going to show you, if you have a GPU available to you, your command to open that is going to look a little bit different. It's going to be salloc -- partition. Actually, this time I'm going to put accounts because I don't want it to look in Wasser, because only UWIT has this partition. So -- account equals UWIT -- partition equals, and this is where I'm going to grab this partition and paste it here. And here's another difference, -- GPUS equals 1. You don't have to put GPUS equals and then the type of GPU and then :1 anymore, because it knows by the partition that you're giving it what kind of GPU that you want. -- mem equals just a short job or a small job, and then -- time equals 5 minutes again. And that's what we'll do for that. And so now I'm in a GPU called G3010. Okay, I'm going to exit that again. So you see now I have my new GPU job in my GPU partition. Okay. All right. So I showed you how to run a batch job. But what if you have the same type of command that you want to either run many, many different times with different parameters, or you want to apply your software to many, many files, but it's going to be the same command being applied to all files? Well, the best type of job for you is to use an array job. And so I've done the same, we're using the same loop script again as our command. But I've built you this script called loop_array.slurm. So nano loop array.slurm, so that you can see the color coding. Again, we have the whole explanation of what is going on down here, which you can read later. And then up here, we have almost the same thing. So again, we're giving this a job name. Instead of it being loop_job, it's loop_array, going to the checkpoint partition. 1 node, 1 task, memory 1 gig, because we know that this is very short jobs. But this is the difference. So now, instead of this just sending one single job, when we say an array of jobs and you give it an index 0 to 9, so we're using 0 indexing here. So 0 is actually the first one. So this is 10 jobs. So basically this one script is going to send out an array of 10 jobs that are all going to be doing almost the same thing. And then down here, it's going to be explaining what this is doing. The other last the last change about the sbatch directives in this case is that it's still going to the log output directory, but instead it's giving the job name again. But with array jobs, it is the shorthand is %A is the job ID, that longer number, and then the sub job, so like the number of the job inside of the array is going to be attached there with this %a into our output file. So we'll see what that looks like. But what we're going to be doing here instead, we've used some bash, the coding language bash, which has great resources online to learn how to do some of this. So we can make our variables up here, and then we can pass them into our command. So remember that our loop_script.sh takes a starting value and an ending value, and it just counts as it goes along until it reaches the end, and then it prints our completion message. So instead of just putting 0 and then 1 million in here, and then maybe doing that, maybe instead of just counting 0 to 1 million again and again and again, instead now we want to say, okay, I want one of these jobs to count 0. Actually, it's going to be up to 4,999,999. So it's going to go 0, 409,999. And then what if the very next one we want it to count 5 million onto the next 5 million, and so on and so on. The way that we can do that, we can use this variable called Slurm array task ID, which is actually just this index. So this variable is just a single one from 0 to 9, a single integer from 0 to 9. So you're using this variable to do math. And what you're doing, you're going to take this variable and you're going to multiply it by 5 million. And then you're going to use that start variable as start, but you're going to add 5 million to it minus 1. And that's so we don't have overlap in our range windows of the numbers that we're going to have this loop script count for us. And so the very first job, it's going to be array index 0. So this Slurm array task ID is actually going to be 0. So what's going to be calculated inside of this operation is going to be 0 multiplied by 5 million. And that's going to be our start variable. And then 5 million, then 0 again is going to be added to 5 million. So it'll be 5 million and then minus 1. So our start variable for the first job will be 0, and our end variable for the first job will be 4,999,999. Then in the second job, it's going to be the index of 1. So this is going to start as 1 multiplied by 5 million. So our starting count is going to be 5 million in the start area. And then that's going to add 5 million plus another 5 million minus 1. Okay, so this is all very abstract. I'm just showing you that you can use these Slurm environment variables to do math and to start controlling your scripts and send out this array of jobs that are just going to count different ranges of numbers in a sequence. So if I control X to exit the Nano app, then that exits. I didn't make any changes. Now if I do sbatch loop underscore array dot slurm, I will see here that my jobs will start on my queue. So I have job, this is my job ID or my array job, and then the sub job is 0 through 9, just like my array index was. So these are going to take a little bit longer because they're counting now to 5 million instead of 1 million. But if we go into our log, cd into log, ls-ltr, we see that we have our log files starting to populate, or our output files. And now some of them have started to complete. So once that last one, yes, okay, so they're all completed now. So I just ran an array of 10 jobs, all doing the same thing, but slightly different because I passed different variables for the start and end. So if I look at the very first job in the index, what the message was, I see that it did iterations 0 to 4,999,999, and it took about 30 seconds. If I use up arrow, it will get me the previous command. And look at the next one. It says that I started at 5 million and I went up to 9,900,999. About 30 seconds again. The second one, same thing. It continued the sequence, and it's just going to continue counting up and up and up for the number of jobs that I asked it to do. All right, that's a little heavy because I got into variables, which isn't really the point of this, but if you don't think about the variables as much and don't harp on what they're doing, if you just think, hey, I have this job that I sent off and it just executed it 10 times with slightly different preferences, then that's a great way to kind of think about that exercise. Do we have any questions? Would there be any issues if the sub-jobs required more compute resources than allowed for my account, or would it know to do as many as sub-jobs as it can? Okay, so basically if you had requested 1,000 jobs instead, but if your group only has 40 CPUs, and this is basically requesting like 1 CPU per job, and you just sent it to your partition, it will just run 40 jobs at a time, and the rest will start to go as the resources free up. So that means that, okay, cool, yeah. I'm gonna keep going. Is it required that the array is all integers? Could it be, for example, I think it could be non-consecutive numbers, but I would check, because I think I remember reading that in the Slurm documentation, but I would double check if I were you, if you were gonna explore that. So, okay, can we provide non-numeric vector such as files in the folder directly, or is it just with sed and an additional sh script? Okay, no, so you can attach the array index to files, and that's our next exercise. Okay. Why did this job at the 6th iteration complete first? Should they complete sequentially? So no, okay, so that's a good point. So I should have said that these are not, so the command itself is doing a for loop, but that is completely independent to the array of jobs that we just sent out. We were actually demonstrating the capacity for massively parallel problems. So all of these problems are completely independent. They don't interact with each other in any way besides the variables that we gave it, which was just numbers. So they can be completing their job without any kind of communication with each other. So those were all running in parallel. So it was really just a case that like the 6th one, maybe completed before the 1st one. And it just kind of happens because they're all going. And so whichever one completes first and shuts down is going to be the 1st one that is reported. Okay. I've used non-sequential numbers. Oh, that's good. Good note from Sarah there to William's question. Good. Okay. All right, I'm gonna keep going because you guys seem like from your questions that you're like super jazzed about what is coming next. Or you will be once I tell you. So I'm gonna go ahead. Kyla, could you please in the chat put the resources for this next part? So that would be the links to the container and the data files and all of that. Okay, so we just talked about how to do a single job, which was sorry, let me just clear this off so we don't get too much going on. Okay, ls-lpr. So we just talked about our loop job, which was just a single batch job sending off that for loop, which is in our script, and starting at one number, ending the count on another number. Now we just talked about our array job, which is kind of the case of what if you have some envelopes that need stuffing. So you've got your wedding invitations that are there and you just need help from a group of friends. They come over, they can all, without having to really talk to each other too much, everyone stuff an envelope, apply the labels and send them out into the mail. And you can have these different workers or these different jobs happening all at the same time, but they don't need to communicate with each other. That's kind of the metaphor that we have for an array job. All of these jobs can be happening in parallel. They don't have to wait for one to complete the next and the next. So if you have a protocol where you need things to kind of happen in this sequence, then you'll have to use this wisely and really only like complete one part per task. But anyway, that's the idea. So the next thing I wanted to do is talk about how to use a more realistic example than what we just talked about with that simple for loop, right? Okay, so there is a software that I prepared as a container called locator.sif. This is a Python package that actually it's a neural network that takes genotype data from a set or a population of individuals. So it could be people, it could be plants, it could be elephants, it could be whatever it is that has DNA. If you have a good representation across the map, it will train the DNA based on those individuals, and then when you give it a set of unknown genotypes or unknown DNAs, it will try to predict where in the world that organism was actually occurring on the map and produce for you a predicted latitude and longitude. And so that's what is coded into this container called locator.sif. A container is just a isolated kind of environment where your software is, and it has all of your dependencies wrapped up into a shareable and scalable container. So that's what's called. I'm actually giving a workshop about containers next week. So Kyla can put the registration for that if you want to know more about containers, but she has shared in the chat the original research article for Locator Neural Network, which is the container that we're using, the GitHub repository for Locator Neural Network, the Docker file that I made to produce the container, and then the Docker Hub repository where you can pull the container, which you don't need to do for this exercise. And then finally, a data set of Populus trichocarpa, which is black cottonwood trees that grow, this species grows in Canada and down into Washington as well. So what we have here is a bunch of DNAs from the leaves of these trees, which I'll show you if we change directory and go into data. And we look in this, POTR is the Populus trichocarpa abbreviation. So if you head -3 for just showing the first 3 lines of this, we'll see that, so these are all of the genes that it's actually sampled. So from the scaffolds, this is one individual and all the DNA is just coded as 0, 1s, and 2s in dosage format. So that's our training data. Along with, we have one file here, just as an example. This is the coordinates for almost all of the trees. And these trees that have NA, these are the ones that it's going to predict for us. So it takes the coordinates where all of those DNAs were collected. It trains the neural network based on these ground truth DNA results, and then it predicts the location of the trees that we don't have information for. So the point I want you to know is that that's kind of what this software is doing. But for this exercise, we're really just going to show you how to pass each one of these files of these data sets with different trees being treated as unknowns into an array job. So here's another one. So you see here that a different tree is being treated as unknown. And this is a way that you can train a neural network to not overfit. You want to make sure that it's not training just on a small set of trees. You want it to be a broadly generalizable neural network. Okay. So I'm going back to the basics directory where I have my scripts. We're going to jump right into this array job with nano. So locator _nn_array.slurm. All right, so the same stuff is available up here. But as I said before, you remember we were in the data file or directory, and we had POTR _m_pred. That was all of the geographic locations for the trees. But we had pred0.txt, pred1, pred2, pred3, and pred4. So we have 5 files in there. And we want it to build a neural network, but using all of each one of these files as a separate job to build 5 separate neural networks in parallel with each one of these files all at the same time. All right, so let me explain. So that's why we picked our index to be 0 through 4. So that's just 5 jobs in this array. And everything else is the same as previous. So what we do is first we make a variable called files where we're listing in one column. That's what ls-1 does. I'll show you on this side. I'll just click cancel my queue. So if we copy this, this is what's going into that variable files. And now we're taking our array index or our Slurm array task ID, which is an integer 0 through 4. And we're grabbing out one line in each or in this variable called files. So for the very first job, it's going to grab line 0. So the file that's going to be passed to our new variable called file is going to be data/poder pred 0 right there. And that's going to be our first job. Our first array in this job is going to be executed on that data set. And then when our array is at sub-array job number 1, then it will grab the line at index number 1, and that will be the file. So it will be on this one. And then if we look at our entire command down here, this is where it gets kind of complicated. So I'd encourage you to read the description of all of this. But because it's a container, we're going to use apptainer and execute the container in a clean environment. We're going to bind our file system. We're going to call our container. Inside of our container is Python. And inside of the container, the Python script to start the locator neural network is within a directory called locator scripts and then Python. It takes the arguments matrix, which is where we're going to pass it our DNA. And then it takes our sample data, and that's where our variable file is going to come into play. So it's passed in down here. So the first file is going to be used to build the neural network. So the samples that have known geographic location are going to be used to train the neural network. And then locator is going to predict the unknown files or the locations of the unknown trees. And it's going to output all of that into a directory called out, which I have to make. And it's going to give this prefix array poder predictions. And then I just want to, again, pass the array job number as a suffix to that file. Okay. If your heads are spinning like tops, then I hope when I execute this, it will become more clear. So I'm going to go ahead and Control X to leave. I'm going to mkdir out because it will not know where to put my data. If I don't make this, it will throw an error. So that's where all of my results are going to be stored. All right, before I do that, I want to make sure that my queue is visible so that you can all see it as the jobs come in. So I'm going to be submitting locator_array.job with sbatch. So it's defaulted again to Wasser account, and I sent it to the checkpoint partition. In just a few seconds, we'll see them pop up here. Oh, that's not nice. Nodes required for your job are down, drained, or reserved. That's not good. Okay, so it might be that they're not downed or drained, but that we're all just trying to do the same thing. So I'm going to go ahead and nano into. If you ever need to cancel a job, you would just grab the job ID and you would do scancel. And I'm going to go into my locator array job. Whoop, spell it right. And I'm just going to change this to partition compute just to make sure that it's going to work. Okay. Sbatch locator nn array. Spell it right. Okay. So now it's going to submit this. Okay, and now it's going just fine for me. So you see that I have my array jobs 0, 1, 2, 3, and 4. And if we remember our the files that we're using were 0, 1, 2, 3, and 4 as well as the DNA. But if I go now into log, okay, so ignore these ones up here because they were from previous. but these are the ones that I'm looking at right now. So one of them already finished. They finished in about 30 seconds. We can start to look. This one's still going, so I'm going to use tail dash dash follow. Oh, it's already finished actually, so I'm gonna quit. I'm gonna, instead of using tail dash dash follow, I'm going to use more to explore this. Okay, so the very first information that we get is that echo file that I ran there. So if on this side, all right. So this is a very good tool. If you echo the variables that you're building here, it will actually print to your output file what the file was that was being executed for the first job. So if I echo data slash, or sorry, if I echo the file, I see that my very first line of my output is the file that's being worked on for this job. Then we have some messages from locator, and it's just saying that I haven't started this as a GPU job. It's telling me that I have this many genotypes after filtering remaining, and then it just starts with my epochs. So it's training, then down at the bottom, it's not a very good error or median because I only used 1,000 genetic markers instead of the 34,000 that were available from this. Okay, so I've got a question from Jeff. On the SQ-U me, what does the status PD mean as opposed to R for running? So yeah, pending. And then let me see your, yeah, so completing job is the CG. Yes, so Jeff just put in an extra information for us that when we're looking at our queue, if you see that your job is under the ST column running or R, that means running. PD means pending, so it's still waiting in the queue. And then CG means completing the job. All right, let's keep on. So I'm gonna clear again. And now I'm just gonna do head -1. Sorry, I'm gonna LS because I can't remember what these are. Okay, so I'm gonna head -1. So just print the first line of each one of these output files so you can see what I'm talking about with each file was executed. All right, so what it was doing, that line to echo the file for each one of the jobs in the array, the first one was executing with the sample data for this pred 0. The second one, or the array index number 1, was doing the first one, or pred 1, and so on and so on. So what happened was we started a job that actually spawned into 5 jobs in an array, and it applied the locator, or built a locator neural network with 5 different input files. So for Adriana, is that what you were looking for with your question above? Can we provide a non-numeric vector as files? So basically, to answer that question, we have provided a non-numeric network or vector, but it's just a list of files in this way. It could also have been that I have a separate text file and I can do the same thing but cat that text file, and it would go in as a list, and then you could apply that array index to each line of the list. Okay. All right, I only have 21 minutes left, and I haven't gotten through the last, but the coolest of the jobs. But it is a little bit more advanced, so you might have to just kind of follow along. I'm going to bring my queue back up again. But I definitely want to show it because now I'm going to show you a script that combines an array job but it also combines parameter sweep, or trying to apply, just like we with our loop array, how we had different starting and different ending values. We're going to not just pass our files as different operators for our array, but we're also going to pass parameters for the dropout proportion, which is a parameter that can be used for building neural networks to make them more forgetful. It's kind of like it erases some of the neurons that it builds so it doesn't overtrain on some data. So let's go ahead and nano to look at locator nn dropouts.slurm. Okay, so it's the same thing up here at the top, except this time it's going to be an array of 15 jobs. The files variable is exactly the same, so we're going to use the same 5 input data sets for the sample data. But this time we're going to make a file index for each of those. And by that, I mean that our Slurm array task ID is going to be our index 0 up to 14. But every time we're going to divide that by 3. So basically our file index for the first 3 jobs are all going to be the same number, or 0. It's gonna, all of the first 3 jobs are gonna work on poder underscore m underscore pred 0.text. And what's gonna happen is we're going to have all 3 of these dropouts, which we have put into a vector. We're gonna have each dropout variable executed on all, in turn, on each 5 of the files. So we do have a few other variables here. So the way we're going to make that file index, we're going to make our file variable, which is going to tell the job script which file to use as our input sample data. We're coding an output directory. We're adding input matrix, which is the same thing that we had before. It's just coded as a variable. Here's the dropouts that we're using. And so that it will loop through all 3 of these dropouts every time, we also need to use our index, but divide it by 3 and take the remainder so that it loops through all of this. This is all, I'm just running out of time, so I'm sorry I have to go kind of fast through this. This is explained in this part. What I want us to do is come down to the command line and comment out the main command so that we can just make all of our variables into our jobs and see all the output messages. So go into here with nano, comment out the command so that it will not execute locator, but it will just print all of the work that we have done to establish this here. And save that. So when I sbatch, spell it right. Now we'll see my jobs on the queue appear and disappear very quickly. Yep, it didn't even have 10 seconds to have them appear. They're all canceling. So if we go into log, now I have all of my 14 outputs here. If I start at the 0 indexed output, I can see that my file index was 0. So that the file or the test set being used for this array job is the pred 0.text, so the first one in the list that we have of files, and that the dropout proportion being tested is 0.25. If we go to the next output file at index 1, we're still at file index 0 because we want this to only change every 3 times, every 3 indices. Our input file is still pred 0, but now our dropout that we're testing is 0.5. And the same thing in index 2. So still, file index is 0, same input file, but now it's on the last of the vector of variables for dropouts that we're trying to test. But that completes all the 3 dropouts that we're trying to test. So when we go into the next output, now our file index has changed to 1. We've moved on to the next file, but we've restarted our loop at the first of the dropouts, and now we're applying this dropout to our neural network, which is being trained with our new sample data, which is pred1, and so on and so forth, until we get to the 6th, where it moves on to the next file. So the point here oh man, of course I can't spell. The point here is to continue to use this Slurm variable to do math and to use it to provide these variables to continue moving through all of the files that you need and execute them in parallel and control the outputs. So if we do uncomment that and save our changes, and now if we submit this again, it's actually going to start the locator neural network. We'll see our jobs come up here. Still have 22, folks. Thank you for sticking around. I've tried to put too much into this workshop, I think. But I'm going to be sticking around for another 30 minutes to answer more questions. So once this is done, if you do have questions broadly about Slurm, hopefully, but if you have even more questions than that, I'm going to be here to answer them. Should be finishing up pretty soon. So I'm going to go ahead and move into the log. All right, some of them are finishing up. Now I can use checkpoint again, which is good news. Sometimes checkpoint can get bogged down when we're all trying to send files to it or jobs to it. So you see that these first 14 jobs were the ones that we did previously where we didn't have the command enabled. And these last ones, okay, so they're all canceling now, so I'm gonna look at it. All right. So here's this one. If we apply more to this, we can explore the file. So at the very top, file index is 0. It takes this as the sample and then our 0.25 dropout, and it continues going through the epochs until it's done. So all of the files are going to look like this. They're just going to have different input files. So I'm going to go back up into basics and then cd into out so that we can look at our output files. So these are the typical output files for locator, where it has a .json file, which are all of the parameters that we set up. Our .preds, or our underscore preds, this is where the predicted coordinates come out. So this was the prefix that I used, and then I attached to the output the dropout proportion that we use for this run in particular. And then this Slurm array index ID, that means for the second array job, these were the results. So just to look at this really quick, it's provided the predicted longitude and latitude for all of these trees, which were unknowns, and saved it into my output directory. And I used those same variables that I set up to make the output files and organize my data very nicely. Okay. Kyla, if you could please put the workshop survey in there, and you guys let me have it on the workshop survey because this is the first time I'm doing this workshop as remote, and I think that it's a bit advanced. So if you think that it is the case as well, please just go ahead and put all of the comments. You're not going to hurt my feelings. I'm really just doing this to be as helpful as possible. And I'll probably do something similar to this workshop in a future iteration. So I want to be able to learn from this. But now, if you have a question and you want to continue putting it into the chat, that's fine. Or if you would like to just unmute yourself and ask your question,